So we're looking at lesson 1, and basically the fundamentals, the basics. This one's our biggest lesson of the first 9 lessons. This almost feels like 2 lessons because it's so long, okay? Now look at all the things that we're going to cover over this lesson. We're going to look at basic multiplication, by hand of course, fractions by hand, percents, exponent rules, so on and so forth. If you had to categorize, let's say the top 3, which one would you say students your age struggle with most? Fractions is a big one. What else? Factoring is another big one. And if you had to do one more out of all these, which one do you think not only is on tests more, but also people struggle with more? Quadratic, yes, but quadratic kind of lends itself to factoring to an extent. Systems of equations they do struggle with, but not as much. And I'm going to teach you how to use the calculator a lot this week, the TI Inspire. And it'll help with that, but also I'll show you how to do it by hand very easily. To me, in my opinion, it's this. Exponent rules. And you'll see what I'm talking about when we get to it today, okay? Alright. Let's see what you know. Let's see what you remember. We're looking at geometry formulas. We have a circle with a C equation. What is it? Circumference. What does that equal? 2 pi r. So I heard both. I heard pi r squared and I heard 2 pi r. This is a very common mistake among students. And the way that I will teach this to students is I would say, guys, which one of these is 2-dimensional? Pi r squared. It's 2D because of this. This one is 1-dimensional because it's to the power of 1. Which one is 2-dimensional, guys? Circumference or area? Area. That's a good way to remember that the pi r squared will go with area and the other one's 2 pi r. What's the other way that we could say 2 pi r? Pi d. Perfect. Now we have a square. Let's say that the side was x. What's the perimeter of the square? 4x. And these questions on the quizzes that you have throughout these lessons, they're timed probably 12 to 15 minutes. Some have 38 problems, some have 60. But about 12 to 15 minutes is a good gauge for you to do these quizzes. And this is going to be on the memorized portion, to just fly through and remember, okay? So what would the area be of this? X squared. Or x times x, but I prefer x squared. Now we have a rectangle. What's the perimeter if, let's say this is L and this is W? 2L plus 2W. What's the area? L times W, base times height. Alright, we have a nice triangle over here. Now there are different types of triangles. What type of triangle is this? Testing your knowledge of just terms as well. Don't be shy. Yeah, scaling. And scaling means that there are the angles, no angles are the same. No sides are the same. And furthermore, none of the angles equal what? 90. So this is a non-right triangle. With this being said, what's the equation of an area of a triangle? Base times height divided by 2. So 1/2 times base times height. So let me color coordinate this for you. This is the base. Do you have a height? Not natural. One isn't given naturally per se, but this would be the height. Because the height and the base have to. They must meet at what angle? A right angle, a 90 degree. You with me? Okay. Let's keep going. What shape do I have here? Cylinder. What's the volume formula for a cylinder? Many of you know different volumes. We're going to tie them together. Pi r squared times height. Has anyone ever seen this differently than pi r squared times height, like on a formula chart? It has been differently. Just want to see if you know it. So they've shown it like this sometimes. What is big B? This is the area of the base. And the base on this would be a circle. So it's a circle that is stacked pretty much with this height to give you volume. This is a cube. What's the volume formula? X cubed. Now guys, there are things about this that I'm going to show you that are a little bit extra, pun intended, on with these shapes that I want you to learn relationships of these shapes, okay? So that you don't have to do so much math and show all the pieces to these things. Like you would know it basically a little bit from conceptual memorization. Can someone tell me what the shape of this base is? Square. So if it's a square, what I'm asking you to tell me now, what would that length be in variable form? Testing your knowledge too. You're close.
Square root of
So we're there. We're almost there. We might have forgotten a little bit. It's a 45, 45, 90 for sure. Let me highlight what I'm trying to show you. This is that 45, 45, 90. Otherwise special right triangles. Where this would be x, x, close, x root 2. So this diagonal would be x root 2. If I did the math and I created this triangle, I know that looks a little bit weird, but it's basically showing from this vertex going through the shape to this vertex. You see what I did just now? It would be, this would still be x root 2. What's this? Height, which would be x, right? And if I did the math on this, that diagonal right here that I'll highlight, let's say in orange, for quick memorization, is x root 3. And guys, if it doesn't come up in PSAT, it will in SAT, and it will in ACT. Might as well know it now. Okay? Let's look at this three-dimensional shape. What's the name of this three-dimensional shape? Rectangular prism. And what's the volume?
length.
Length?
So base times height is length
Width and height. So length times width times height. Bam, bam, bam. Alright, so good little review of geometry formulas. Let's now look at Pythagorean theorem. What's Pythagorean theorem? Yeah, a squared plus b squared equals c squared. The ones that you should have memorized for sure, guys, are these three right here. These are the ones that you will predominantly see, especially the 3, 4, 5. Okay, help me label the right angle. Well, that's a little bit easy. That's just right here. Can you tell me, where does A go?
Vertical or horizontal.
Either one, the vertical or horizontal. So that means the hypotenuse must be what letter? C. And I like the way he was saying that. It could go on either the smaller or the bigger one. So I'll ask students, where does the A go? And a lot of students say the smaller one, because they've been taught that. But that's not the case. Why doesn't it matter where A and B go? What mathematically tells you it doesn't matter? You're adding. Here we go. Addition is commutative. Do you know what that means?
It's the same backwards.
Order doesn't matter, right? So 2 plus 5 is equal to 5 plus 2. What else is commutative? Or order doesn't matter? Multiplication. So 2 times 5 is 5 times 2. But when does order matter? Division and subtraction. Let's do subtraction first. So 2 minus 5 is not the same as 5 minus 2. Just like 2 divided by 5 is not the same as 5 divided by 2. Order matters with those two. And you'll see why I tie those two other things here soon. So let's just put A here, and we'll put B here. Alright. A Pythagorean triple is a set of 3 numbers that satisfy this equation. In other words, we could say 3 squared plus 4 squared is equal to 5 squared. Because 9 plus 16 is 25. How did they get 6, 8, and 10? They multiplied all numbers by 2. In math, what did we call this in geometry? Nice. A scale factor. Okay? So you're multiplying them all by 2. So and you probably remember this from 3, 4, 5. And a bigger one would have been 6, 8, 10. This is scaling by 2. Just like this would be scaled by what? 3. And last? 4. By 4. Now, this tied with scaling, but it also tied with another concept that you remember from geometry. By name, do y'all remember what I'm talking about? What other concept?
Dilation.
Okay, so dilations, yeah, you're exactly right. That's a dilation is another way of saying scale factor. But what I was talking about were similar triangles. Okay, we have like triangle ABC is similar to triangle DEF. You see what I'm talking about? So with ratios and proportions, I want you to categorize and know what fits with what and why. That's where these tie into play. All right, 5, 12, 13. What's 5 squared? 25. What's 12 squared? 144. Add those up together, do I get 13 squared? 169. So this is a Pythagorean triple. Would 5, 12, 14 be a Pythagorean triple? No, because 5, 12 won't give you 14 squared. You with me? It has to satisfy this equation to be a Pythagorean triple. What's 7 squared? 49. Oh, here we go. What's 24 squared? We don't know. What's 25 squared?
625.
There's always one that knows this. It is 625. Okay, no worries, no worries. How do you know it's 625?
Swimming.
Oh, nice, from swimming. Okay, groups of 25 from swimming. Nicely done, I like that. Other forms that people would say were how many dollars, quarters were in $1, you know what I mean? So if there's 4 quarters in $1, there'd be 20 quarters would get you $5 or 500. You see what I'm saying? However they did that, and some people see it differently, I'm going to show you something really cool right now. Alright, the math that I'm about to show you, you will not learn in a math class. You won't. You'll learn it in UIL number sense, but you won't learn it in a UIL or in a normal math class. My hope is that you adopt these ways to do things, okay? Again, if you look at it, you're like, that's not for me. No, that's too confusing. I hope that you don't run away from it just like that, but that you actually try it on for size, and if you like it, use it, because you will be beast when it comes to number sense, okay? Here we go. The shortcut is, if something ends with 5, and it's squared, then it must end with 25. You with me? What number comes after 2? 3. So multiply. What number comes after 2? 3. What's that multiplied together? 625. Done. You just learned one shortcut of many that I want to teach you. So let's say this was 75. Because it ends with 5 and it's squared, guess what it will end with? 25. Same thing. What number comes after 7? 8. So what's 7 times that 8?
56.
That's your answer. Okay, let's do one more. What would 35 squared be? Don't be shy, go for it. What's the total answer? 1225. It was 5 squared, and it will end with 25. 3 times the next number, which is 4, will get you the 12. It will always work, guys. Always. Okay? These are always working if and only if the last number is 5. Now, I said 4 before. And people are like, ugh, I don't know what that is. So, here's what I'll say. What I'm about to show you now is very close to what I just showed you. And you can use this to improve your factoring skills and your folding distribution skills. Big time. So I'm not just teaching you these shortcuts for these easy problems. The concept that I'm trying to drill into your head will help with other more difficult problems. Okay? For instance, is this the same? Yeah. Like, this almost looks like FOIL method. Okay? Are these the same? Okay? What I'm trying to do is eliminate your work too. Guys, you're fighting against the clock with these tests. You gotta learn how to take them fast, okay? With little work to be shown. Here we go. FOIL method. So F for first, which is what? 400, because you're multiplying. Now you have this outside term, which is what? 80. Now you have this inside term, which is what? 80. Look at that. There's two 80s. Emphasis on the 2. It does that every once in a while. And then finally, the last one will be, let's use purple, 16. You ready, guys? So this is 160. So this is 560, otherwise 576. Are we good? That's a lot of work. And this is the only time I'm going to show you a lot of work, is when I first teach it to you. After that, we all do it in our heads, okay? Watch. We're going to do the FOIL method, but we're going to do it backwards. We're going to start with the last term. Now watch carefully. The last term would be 4 squared. That's 16. Carry the 1. Okay? Then we're going to do 2 times 4, which is what? 8. Times 2? 16. Plus the carry is 17. Carry that new 1. Okay? And last but not least, we're going to do the first one. So we get 2 squared is what? 4 plus the carry? 5. What we just did, if I were to go back to your notes, I'm going to skip a little ahead, is this one right here. What's A plus B quantity squared if I were to distribute and get rid of parentheses? So yeah, it's A plus B times A plus B. But if I were to FOIL method this out with no parentheses left over, what would I write right here? Guys, this is what we're doing. But we're doing it this way with the FOIL method, reverse FOIL method. Do you understand? Let me do some more examples so that you can see them. Let's say that we had, I don't know, 37. We are doing B squared first. That means we're going to concentrate on this one. So 7 squared? 49. Carry the what? 4. 3 times 7? 21 times 2? 42. Plus the carry of 4. 46. Carry the 4. And last but not least, we're going to do this A squared piece. Okay? So that means 3 squared. Which is what? 9 plus the carry? 13. I hope you use it, okay? You have to practice it to get fast. We'll practice some more here in just a bit. But let's go back to where we were at in our notes. Right here. So 24 we learned was 576. And 25 was 625. Right? Now, let's do scale factors and get better. Because to be able to do what we just were doing, we have to build our multiplication. And some of us learned our multiplication fraction in 3rd grade like this. Some of us need to refine that, okay? So let's recognize the multiple of 2. What would this be right here? 10, 24, 26. Good. 15, 36, 39. Remember, you're multiplying this now by 4
20, 48, 52.
and then 52. Good. Let's do now this. What's scale factor of 2?
14, 48.
Good. Now factor of 3?
21, 72.
Good. Good. So some people are a little faster than others. No worries. We're building that, okay, through experience and practice. 28, 96, 100. Nicely done. We will get even faster as we go. Special right triangles. There are two triangles. Who can tell me why are they so special? They're what?
They're angles. They're like they're at the the 30, 60, 90.
You're right. The 30, 60, 90 relationship and the 45, 45, 90 are what make them special. So like if this was 31, what would this be? 59. If this was 29, this would be 61 and so on and so forth. Those aren't special anymore. The only times they're special is whenever they're these numbers. Okay, so what we're going to memorize are these two tables. We're going to memorize 30, 60, 90, and then we're going to memorize 45, 45, 90, because they're everywhere in our tests, especially with PSAT, SAT, and ACT. Let's see if we remember these special right triangle side lengths. Okay? What's 45, 45, 90? Good. What's 30, 60, 90? X root 3, I hear it.
2x.
And 2x. Why?
Because the 60 is twice the length of the 30, and then the hypotenuse, you can use Pythagorean theorems to figure out x root 3.
Okay, Pythagorean theorem. That's right, Pythagorean theorem, right? Can someone tell me what shape did this 45, 45, 90 triangle come from? Square. Watch. First time you see this, it's actually kind of rewarding. Let's say this is x. Pretend it's a square, right? So all of these are x. So if all of those are x, how can I find the hypotenuse? Well, I'm just going to use a squared plus b squared is equal to, let's say hypotenuse is question mark. We don't know what that is. What's x squared plus x squared? 2x squared. What would you do mathematically to get question mark by itself right now? Square root. Love the progression and speed, guys. So now you have question mark by itself. Can you take the square root of x squared?
Yes.
Yes. What does it come out as?
X.
X. Can you take the square root of 2?
No.
No. That's where that x root 2 comes from. Okay? Just FYI, so hopefully it helps you memorize it even better. What shape did the 30, 60, 90 come from?
Rectangle.
No, and a lot of people think that. No one has said it correctly yet. Not a rectangle. Try to think of another shape.
Rhombus.
Not a rhombus. That's a good guess. Those are two good guesses, though.
Trapezoid.
Not a trapezoid.
What's the sides?
There it is.
Lateral triangle.
An equilateral triangle. An equilateral triangle is where this comes from. Ready? There's a fancy word for this segment right there that you learn in geometry. Let's see what you know. Do you remember what that was called? It was called a perpendicular bisector. Perpendicular because it met at 90 degrees. And it cut these two angles perfectly in half, or that angle perfectly in half. So that means these sides over here were also congruent. Okay? So, here we go. Let's say that from here to here is x. What's the original hypotenuse? 2x. And let's say that I was looking for this one right here. And I'm going to show you how to use these tables here in just a bit too, guys. So we have a squared plus b squared is equal to c squared. I've made a mistake. Help me find it. And what I just wrote, this equation, there's a mistake. What is it?
That's not.
Nice job. Parentheses right here. Okay, so if I distribute that power per se, what should I have written? 4x squared. Our goal is to get question mark. What do? Subtract x squared. So I get question mark squared equals 3x squared. If I take the square root of both sides, x root 3. Perfect. Okay? Let me show you how to use these. Some people are going to use SOHCAHTOA and they're going to take forever. But if you can identify that they're 30, 60, 90, 45, 45, 90 degree triangles, you can fly with this stuff, okay? Let's say that the hypotenuse was 10. The hypotenuse is 10, watch this, which is across from 90. So in 90, I'm going to put 10. And I'm going to set these two equal to each other, and I'm going to solve for x. What's x? 5. So guys, that means everywhere where you see a 5, or sorry, everywhere where you see an x, here, here, and here, is going to now be a 5. So this will be a 5, this will be 5 root 3, and of course that becomes 10. So across from 30 will be 5. Across from 60 will be 5 root 3. Quickly, just like that. Okay? Let me give you a little bit of a difficult one with the 45, 45, 90. What if the hypotenuse on this guy was also 10? On this table, where does the 10 go? X root 2, right? So x root 2, we're going to set those two equal to each other because that's what we're trying to solve for. We're trying to solve for x. And you get x is equal to 10 over root 2. Is that allowed? No, we can't have radicals in the denominator. So we need to rationalize. That means we need to multiply by what? Be careful. By a form of 1. Root 2 over root 2. So root 2 over root 2. What does the denominator become? 2. What does the numerator become? 10 root 2. And what does the final simplified piece become? 5 root 2. Not 5 root 1. Don't distribute on both, just on 1, because it's all one term through multiplication. So 5 root 2 and 5 root 2. So that would go here, and that would go here. Hopefully now you've mastered that, okay? We did spend time for a reason, because I want you to be fast and accurate with those anytime you see them on tests going forward. The sum of the degrees of the angle measures of a triangle. So the angles inside of a triangle, if I add them all up, how much should they equal? 180. Okay. The number of degrees of a straight line?
0.
Not 0, but 180. So don't overthink this. Those of you who have taken pre-cal, have you taken pre-cal yet? Okay. So those who have taken pre-cal, they remember from the unit circle that if it has a horizontal, that this looks like 0 degrees. And if you rotated it up, this would be 90 degrees. All the way here would be 180, so on and so forth. Don't confuse it with that. This is just the simpler saying straight line, 180. Otherwise, what's that fancy word they say whenever they're 180? Starts with an S. Supplementary angles. Okay? The total arc measure of a circle in degrees. 360. The total arc measure of a circle in radians. 2 pi. Why is it 2 pi?
The length of the radius goes around the circle 2 pi times.
Yeah. Otherwise, the unit circle that people have already taken pre-cal, some have. Those of you who have taken pre-cal, the unit circle, how big is the radius? 1. Circumference is this. So if I'm talking about the circumference of that circle, and the radius is 1, then what would the circumference be? 2 pi. It's just another way of saying, okay, look, 360 degrees is the same as 2 pi radians. Just like 180 degrees is the same as how many radians? Pi. Guys, these are just conversion factors. Like you would say 12 inches is the same as what? 1 foot. Stuff like that, okay? They're just conversion factors, relationships between one another. All right, decimals, percents, and fractions. We've got to be able to go through these fairly quickly to be able to work with fractions. So you guys said people struggled with fractions and whatnot. Chances are that might have started here, okay? What's 1/10 as a percent? 10%. So this is a little bit more difficult to see than this, okay? And just like some of you said 0.1, I see the decimal first as well. How do you change a fraction into a percentage? Okay, you're right. Move the decimal, but mathematically, what are you doing? You're multiplying by 100, which looks weird. And even for me sometimes at the level when I was at your age, when I saw 1/10, and if I was making it into a percentage, I was multiplying by 100. To me, that didn't make any sense. But if I thought about it a little bit more, you're trying to look at 100% and divide it into 10 parts. You with me? So 100 divided by 10 would give you the 10%. Otherwise, mathematically, what does 100 over 10 reduce to? 10 over 1. That's how you get it. So 10%, now if you wanted to move the decimal to the left, you could write it as a decimal of 10, or 0.10. Okay, I hope I didn't overcomplicate that. Let's look at 1/5. What is the percent for 1/5? 20%. How about 2/5? Way down here, 2/5. What would that be? 40%. And all you did was multiply it by 2, right? Multiplied 1/5 by 2. And 5 is a cool number because how many $20 bills are in 100? Those of you with jobs? Or without jobs? There's 5 $20 bills in 100. So of those $20 bills, if I had 2, I have $40. Okay. Now let's go through this, and if you have any questions, please let me know as we go through. 1/5 as a decimal is what? 0.2. What's 1/4? 0.25. 3/10? 0.3. 1/3. Yep. So let's do just 2 for now, right? And then 2/5. 0.4. 1/2. 0.50. And then you get 50%. You get 33.33%. You get 30%. And you get 25%. Any questions over what we have? All right. One more. 3/5. 0.6. Otherwise, 60%. 2/3. Yep, 0.66 continuous, otherwise 66.66% continuous. 7/10? 0.7. Let's keep going straight down. 0.75, 0.80, 0.9. And these are easy because you can just move the decimal 2 to the right and write them as percentages. Just to make sure we're good with this, this has to be locked down. All right. You remember these? These used to be those in grade school. How fast can you do them? We're going to do them together. Here we go. 1 squared.
1.
And then 4. And then 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. Ooh, and then we stop. So this tends to be where people stop, okay? Now you learned a trick today that'll help you get this like that. What's 15 squared? 225. You can also use logic to get this. What would that be? 400. And the other ones, you're going to use the trick that you learned today, hopefully, to master these and get them fast. I would hate for you to memorize this. There's too much to memorize in math. There's some things we need to memorize. This isn't one that we need to. I think if we remembered how to do the FOIL method, we could do this by hand. Here we go. I'm looking at 4 squared first. So what do I write down? The 6 carry the 1. Now, 4 times 1. 4 times 2, 8. Carry the 1, 9. No more carries. Last but not least, let's do the first number. 1 squared. 196. We're going to practice this. Look, 4 more times. First number that we're looking at is 6 squared. So we're going to write down the 6, carry the 3. Yeah. And now we're going to multiply these two together. Times 2, 12. Add the carry, 15. So we're going to write down the 5, carry the 1. And last but not least, we're going to look at 1 squared and add the carry. What would that be? 2. 17 squared. We're going to write down what? 9, carry the 4. 7 times 1?
7.
Times 2?
14.
Add the carry? 18. Write down the 8, carry the 1. 289. Notice, guys, how I'm not writing down any work whatsoever. Okay? That's how I want you to build it to. Okay? 18 squared. What's the last number? 4. Carry the 6. Now it'll be 1 times 8?
8.
Times 2? 16. Add the 6? 22. So we're going to write down the 2 and add, or carry the 2 from the 22. So what would be our last number? 322. Or sorry, 3 for 324. And our last but not least, 19. What's the first number I write? 1 carry 8. 1 times 9? 9. Times 2? 18. Plus the carry?
27.
Close.
37.
So I had 9 times 2 is 18, right? Plus 8. Think of those 8 and 8. 16, right? But it's going to be 26. So it'd be 26, carry the 2. And then what's the last number? 3. Nicely done, guys. I hope you adopted the backward FOIL method. All right. These 3 words are shown up here somewhere. Which one of these is a difference of squares? A lot of people think it's this, but it's not. This is the difference of squares. And the reason why that is a difference of squares is if we were to FOIL this out, we get a squared, and then what? Let's do the outside and the inside. Not 2ab on this one. These are different. Because they're not both positive. One's positive, one's nice. They cancel. You got the outside, you got the inside, and then you got the last, which is what? B squared, but what is it? Adding?
Minus B squared.
Minus. Guys, in math, we will cancel to 1 when we're multiplying or dividing. If we're adding or subtracting, what do we cancel to? 0. So what's left, watch, is a difference of squares. This is not a difference of squares. This had an M word with math, oh sorry, not math, but with algebra 2. Do you all remember that fancy word? Not matrix. Nice, yes, multiplicity. This had a multiplicity of 2. So on a graph, it would bounce off the x-axis. Okay? Like if you saw something that looked like this, and this was at 3, it would look like this. These would be the roots if it was hitting at 3 and bounced off. Otherwise, it looks like this, factored out. You with me? So up here it's a multiplicity of 2. That means you really have 2 of these things. They're not going to cancel. So what would this be, all FOILed out? Minus what?
Minus
2ab. Come on.
plus b squared.
Plus b squared. Notice the subtle difference that exists between those two. Are we good? Alright. Guys, please have those memorized as far as what they look like. Alright, coefficients. What are the coefficients that you see in this function right here?
Negative 2.
And 2, right? Just those two, right? What's the constant that you see? Negative 11. What's the degree? Second degree. Now, you see these all the time in PSAT, especially ACT, and if we can't answer basic questions like this, we're going to miss easy problems. What is an integer? And try to tell me, like if I'm a 6th grader, simplify it for me. What is an integer? Because if you can't explain it simply, guys, you don't know it well enough yourself.
A value that's negative or positive.
Not a real number.
But that's whole. Like a negative or positive whole number.
Okay, so he's the closest one right now. He's saying a negative or a positive whole number. And he's saying non-zero. Okay, now look, let's iron them out and put them all together, okay? The first one that probably fits to start you with are natural numbers. If I naturally told you to start counting, just start counting for me, what would you do? 1, 2, 3. You would start with 1. Those are natural numbers. Whole numbers, these are to refine and get the easy ones out of the way, are the same thing. The only difference is that they include 0. And a good way to remember that is that. Integers include both of them, but also the negatives. So 0, is it an integer? Yeah, it is an integer. So is the number 0 positive or negative? Neither. But 0 is an integer. Are we good, guys? Alright. Alright, so we are given these two binomial factors that are multiplied together in their factored form to equal 0. We can say that 2, otherwise x equals 2, and a negative 11, so x equals negative 11, are solutions or answers to the equation. What can we also call them? Nice, those are 2 of them. So zeros or roots. What's the last word that you know them to be referred to as? X-intercepts. Very strong, very strong. Formulas related to linear functions. We've looked at the y-intercept, otherwise known as the slope-intercept form today. We will discuss point-slope formula, which means you are given a point, and your point is right here, and your slope is here, just like your slope is here. And the slope formula is the change in y over the change in x. In linear word problem, slope is often referred to as the rate of change, increase or decrease, and the y-intercept is often referred to as the initial starting value, whatever. And you see this a lot with like the one-time fee that we were talking about earlier. Questions? Okay. Given 2 points, if I asked you to find the midpoint, let's say you didn't know this equation. A lot of people overcomplicate this. Let's say that I have, here we go, I have 86 and 100. You got an 86 on test 1, and you got 100 on test 2. What was your average? Okay, 93. The average was 93. Not many people answer that question that fast. How did you get 93?
Just, it's 14 between them, so you add 7 from the bottom one.
Okay. Now, there's 14 between, and if I do half, that means there's 7 on each side, right? So I could take 7 away from 100, or I could take 7 and add it to 86. How many of you actually were doing that? I would be willing to bet that a lot of you were doing that, but you weren't as fast as what he was to do that in his head. There's an easier, faster way to get the midpoint, because that's too much work with what you're doing right now. And I used to do the same thing. That's why I want to help you get faster. The midpoint between two numbers is simply the average. Add them, divide by 2. So 186 divided by 2. 93. Okay, so the midpoint is the average. Don't overcomplicate it. Don't do too much work. Kind of refine and change it up just a little bit. That's a lot easier, especially with the way they give you stuff, guys. This is the way that you want to use these equations. Let me give you an example. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Let's say 3 and 2. I have 4, 5, and negative 3, negative 2. And I want you to find the distance. In the past, when I was sitting where you're at right now, my teacher used to tell me use the distance formula. You have 2 points, use the distance formula. But I did not like to use the distance formula because it was way too much to memorize. And I think there's more efficient ways to memorize stuff in math. So when I looked at the distance formula, and I looked at it a little bit more carefully, it's Pythagorean theorem. If I square both sides, the square root goes away, and I'm left with a squared plus b squared. So I can create a triangle by going straight down and straight to the left that is a right triangle. Can someone tell me what the length of this x is? 7. What's the length of the other one? 7. Ooh, this was inadvertently. What would the hypotenuse be? 7 root 2. We learned it today. This is a 45, 45, 90. Otherwise, x root 2. So this, the distance formula would be 7 root 2. Okay? What if I asked you to find the midpoint? That's a point somewhere in the middle here, and I want you to tell it to me as a coordinate x, y. Hopefully you're not doing what we were doing before of 86 and 100 are 14 away from each other. Divide that by 2, which is 7, and then add those or subtract those from the ends. What do we do to find the midpoint, guys? You average it. So negative 3 right here and 4, look at this. That means to take the average. What's that? 0.5 or 1/2. What's the average of negative 2 and 5? 3/2, right? Nice.
How do you know which one to put on the numerator?
Well, it's always going to be 2 because you're dividing by 2 numbers.
Or like
How do you know,
no,
like...
no, my answer.
No. I wanted you to ask that question because I wanted to help people who have the same question.
No, I got confused. I thought those were the coordinates, but those are the answers.
Okay, yeah, these are the answers. But some people ask this, how did you know which one to list first? The negative 3 or the 4? And what do I tell them? It doesn't matter because they're being added. And order doesn't matter with addition. A lot of these same themes keep popping up, okay? That's what I'm trying to bring notice to. We talked about this earlier, but this is a little bit different. It's increase or decrease. Okay? Let's say that I went and I bought a video game. I think that good video games are usually like what now? 60, 65 bucks? Let's say 60 bucks. So 60 bucks for a video game, but I ended up paying 67. What would the change be? 7. What's the original? 60. And if I multiply it by 100, this would tell me how much percent tax I was charged. Do you understand? It's the increase in percent. Does that make sense? Okay. Let's go to distance formula with RT. So not the same as this distance formula. These are different. This is talking about the dirt formula. D stands for distance, R stands for rate, T times is time. Let's solve this for rate. What would R equal? D over T. Let's solve it for time. What's that? D over R. And guess what? Out of all these equations, guess which one most people struggle with? I don't know why, but conceptually and using it and being fast with it, which of those three would they struggle with most in your experience? I would say this one. Okay, so just be cognizant of that whenever you guys are doing stuff with dirt. Alright. What did I just box just now? The equation of a circle. What's that similar to? We've seen it now twice. I'm helping you try to memorize these formulas too. Because you don't get a formula chart for your ACT. Pythagorean theorem. Look at this. This is going to be a squared plus b squared is equal to c squared. But HK is the center of the circle. So let's say that this is the center of the circle. Go with me? What's the point? -3, -2. How would that be written in the equation of the circle? X plus 3 squared plus y plus 2 squared equals, what did we say the radius was on this thing? Or the distance formula? Remember we saw for the distance formula? 7 root 2. So if I square 7 root 2, what would that equal? 49 times 2, right? Because you apply it to both, and you get 98. Questions? Some of you forgot. Let me go back a little bit. Guys, when you see things in parentheses, I want you to interpret the opposite. That's how you get a -3. This is the opposite. That's why you got -2. Because if you don't know it already, these values are what goes here to make the whole thing equal what? 0. Just like this would go here to make this whole thing 0. Zeros, x-intercepts and stuff like that. Not the same concept with x-intercepts, but a good way to tie it to memorization. 5 cubed. So 5 3 times. 125. 3 4 times. Or 3 to the 4th power. And when I say 3 4 times, I don't mean 3 times 4. I mean 81, because there's 2 groups of 9. 2 to the 5th. 32, because you see these are 4, which is 16, times the 2 gives you 32. 4 cubed, 64, and 2 cubed, 8. Can someone tell me what number is there, and there? 2. Even though it's not written, there's a 2 there. That means we want the square root of 50. Now, you learn how to do factor trees to do this, remember? And despite the different ways that you could solve this, you might have been led to always start with 2. And sometimes, like in this case, that would work. Because you have 2 times 25, and what can you bring out?
5.
The 5 from that 25. The square root of 25 is 5, and the 2 stays in, and you're done. Do you think I want you always going for the 2? I don't. Can someone tell me, and this would tell me that you know the theory behind it, why should you start with 2? What's so special about 2? What's the first prime number? 2. So all of this is prime factorization. Look at this. If you were to keep going with this, and it will help with other things, I'm not just showing you just to teach you theory, but 5 and 5, your base, basically you can't go anymore because they're all what numbers? They're all prime numbers. You with me? And then you were taught, list them all out, guys, and then in pairs, because this is a 2, you're going to bring numbers out in pairs. Okay? So, what number do you think, instead of 2, what's the first number that you think I want you to start trying to divide that radicand by?
5.
Not 5. Let me show you. Oh, try 4. If that doesn't work, what do you think the next number is? Say again? 9. What would be the next number? 16. Why am I doing this? Because these are squares. And if I can look at the squares, I know that this 4 will come out as a 2, this 9 will come out as a 3, so on and so forth, because I'm talking about square roots. Y'all with me? Now look at 200. 4, 9, 16, what comes after 16? 25, keep going. 36, keep going. 49, keep going. 64, okay. 81, and 100. What number do you think I would want you to divide this by? 100, which again, coincidentally gave us the 2. But my point is that I'd rather you think of those bigger numbers so that when you pull them out, you've already done the work, and it's just 10 root 2. Square root of 27. What 2 numbers am I thinking of? 9 and 3. 9 comes out as a 3. Now, the difference here is you don't have an understood 2. These are cube roots and fourth roots. That means 3 numbers that are the same will multiply to give me 27, and 4 numbers that are the same will multiply to give me 81. What is this first answer? 3. And this last one? 3. When you're doing cubes, you're not doing 4, 9, 16, 25, 36, so on and so forth. What's the first number that you're doing? 8. And then? 27, nicely done. And then? 64, and one more. 125. Good. Let me show you something I want to make sure that you all know. That last one right there, the fourth root of 81, what if I said, you tell me, let's do this one. What's the cube root of 64 squared? What I'm hoping you remember from Algebra 2, are these the same? Are these the same? Yep. Why? Because these are forms of multiplication, and multiplication does not have order. What's the cubed root of 64? 4. Squared? 16. Could you have done that squared and then taken the cube root? You could have, but that's hard. Like you would square the 64 with the practice we did today. You get 4 squared is 16, carry the 1. 24, 48, 49, carry the 4. 36 plus 4, you get 40. Now take the cube root of that. What? You know what I'm saying? So it's always best to do the root first, break it down to its lowest number, and then power it up. Did you understand that? Okay. All right. We will end with this. We have 6 rules, and then we're done for today, okay? So we're going to look at the 6 rules with exponents. Number 1, when I have the same base and they're multiplying, what will I do with the powers? Add them. So you have 2 to the what? 9th and 3 to the... Oh, 5a. Careful, there's those simple mistakes. Not 6a, not 6a squared, you're adding. And 2a plus 5a is the same as 2x plus 3x. It's 5a. Okay? Rule number 2. When I have the same bases, I will have one base as my answer. And this time I'm dividing. That means I'm going to subtract the powers. So what would this first one be? 2 to the what? 4th. This next one?
5 to the 2a.
5 to the 2a. And the last one? If I use the rule, straight up use the rule, I would write 7x to the what? Negative 3. Well, we don't like negative powers just like we don't like square roots in the denominator. So this is going to be flipped when I have negative powers, right? Guys, this can all be understood to be over what right now? 1. So, because this negative is there, what moves downstairs in the denominator? The x or the 7 and the x? Just the x. Just the x. If there's no parentheses around the entire thing, it means just the one that it's attached to immediately, okay? A lot of iron outs that a lot of people struggle with, okay? So this, the x would go downstairs, and the 7 is left. And guys, when you flip it, when you go across that dividing symbol, it's going to change that sign, okay? So think the dividing symbol almost like a force field, if you will. It would just change the signs. If you go across it, the powers change the signs. You with me? All right, let me try to see if I can trick question you one more. If I have 1 over, actually I'll do it like this. I'll do x to the negative 1. Just like that. What's understood to be in the denominator? 1. What does this change to? 1 over x to the positive 1, right? You see how the x went across and became positive? What happened to this 1? Did it flip and go up? No. Some people think it does. It stayed there. And a different 1 appeared up top. That's already understood to be there the whole time. I want to make sure that you're not reciprocating and doing reciprocals, but you know what you're moving and why. Okay? Alright. Powers raised to a power. It's easy to remember this because in between those two powers is a nice parentheses, which 9 out of 10 times means to do what? Multiply. Okay? F of x. Again, going back to f of x. That doesn't mean to multiply just because it's parentheses. Okay? So, what's 2 to the 4 to the power 3? 2 to the 12. What's that equal to? I'm just joking. So that's a lot. So 2 to the 12th is the answer there. Let's come over here. 7x to the power of y.
7xy.
Yep, 7 to the power of xy. Because if you just say 7xy, this is what you've just said. Okay, so be careful with that. Last page. This is what I was talking about before. This understood 1 is still there. And the understood 1 is this one right here. So 2 to the power of negative 3 equals what? 1 over 2 to the positive 3, which is 1 over 8. Remember, this is over 1. So when you move this thing down, it changes the power, or that force field that I was talking about, if you will, to remember it, would be 2 to the power of 3 and there's just 1/8. What does this become? What moves first of all?
Bottom one.
Bottom one. It's going to move up. And when it does, what am I left with?
X,
X to the A times y to the B. Which one moves on this last one? B. So it moves down, so that my final answer is what?
A to the power of 3.
A to the power of 3 times C
B squared.
over B squared. Nice. Anything, no matter how complicated, except for x cannot equal. So anything to the power of 0 will always equal 1. As long as that anything is not what? 0. And what else? Infinity. Those are the only two, and you learn them in calculus. They're indeterminate forms. So 3x to the power of 0, what would this be over here? 1. What's all this mess to the power of 0? 1. Notice, we talked about this earlier. This 2 is out here, and this 1 is right here. So those are the same. So what's 49 to the 1/2? 7. It's the square root of 49. Oh, we talked about this too. 8 to the power of 2/3 would be what? 8 squared root 3, which I hope you're not looking at it like this. I'd rather you look at it like that, because you can do it in your head faster, right? And you get what? 4. One more thing with what we did on last slide, just to help you out. When you have these fractions, guys, how many 2's do I have on top? 7. How many do you have on bottom? 3. They cancel to forms of what? 1. So 4 I've left up top. Just like if you had over here, you had 5 on the bottom, 2 up top, who won? The bottom. By how much? By 3. That's all I have for you. We will do the rest next time.